And the lesson objectives. By the end of this session, you will be able to find values of trigonometric functions using the unit circle. Let's begin. A unit circle is a circle of radius 1 centered at the origin. So here we have a circle where the center is the point 0, 0, so the origin, and the radius is 1. So this is indeed a unit circle. On a unit circle, the radian measure of the central angle theta equals s divided by 1, which equals s. And here s is the arc length intercepted by theta. Let's demonstrate this visually. So here we have the angle theta. The radius is 1 because this is a unit circle. And in red we have the arc s. So this is the arc intercepted by the angle theta. Now in this case we see that s equals theta, of course, because r is 1 and s divided by 1 equals s. So the angle theta equals the arc length s, which of course is just a distance, it's a real number. So we can think of theta as just being a real number. So then what we can do is we can map a real number input value for a trigonometric function to a real number output value. So theta is a real number. We put this inside a trigonometric function and we get a real number output value. So let's explore this further in the next slide. We can let t be any real number on a number line, and we let the point P be a point on t when the number line is wrapped onto the unit circle. So what does this mean? Well, if t is any real number, we can wrap it around the unit circle, like so. So indeed t now becomes our s, it's the arc length. So as shown on the previous slide, the angle here also equals t. But indeed we think about this angle here as just being a real number input. Of course the radius is 1, so then we have this point P here, which is of course on t. Now since r equals 1, we can then find the trigonometric functions of t. Well, sine of t equals y divided by 1, which equals y. Now if you recall, this is what we found, what we covered in the first objective of unit 3.3. Of course we had that sine of t would be, well, y divided by r, but r, radius, is 1. So then this simplifies further, the sine of t equals y. For cos of t, we have x divided by 1, which equals x, and tan of t equals y divided by x when x is non-zero. And from this we can have this, the cosec t equals 1 divided by y when y is non-zero, sec t equals 1 divided by x where x is non-zero, and cot t equals x divided by y where y is non-zero. So therefore, the point P corresponding to the angle t can be written as P, where x is cosine of t and y is sine of t. And we have these here, sine of t equals y, cosine t equals x. So what does that mean? That means we think of x as being cosine of t and y as being sine of t. So we notice how the input t can be thought of as an angle measure or a real number. Because indeed t here is an angle measure, but of course it's also the real number that's been wrapped around the unit circle. So we can think about it as two different ways. Let's have a look at circular functions. When defined as a function of the real number system using the unit circle, the trigonometric functions are often called circular functions. So using reference angles or quadrantal angles, which we've already covered in the previous lesson, we can find the trigonometric function values for all integer multiples of 30 degrees, or pi by 6 radians, and 45 degrees, or pi by 4 radians. Again, we have covered this. Now these special values wrap to 16 special points on the unit circle as shown on the right. Let's have a look. So here we have the unit circle And we have various angles, so 0 degrees, 30 degrees, 45 degrees, 60 degrees, so on and so forth, up to 360 degrees or 2 pi radians. Now, in the previous slide, we saw that x equals cosine of theta, or cos t, and y equals sine t. So then we have these points here that correspond to the angle theta, or angle t, or real number t. So then, as we go around the unit circle, we have all these different coordinates. And if you note, the radius, of course, has to be 1. So if we find a radius, or the distance from the origin to each of these points, it will equal 1 precisely. So using the xy coordinates in the 16-point unit circle, we can then find the values of the trigonometric functions for common angle measures. So common angle measures are the angles here, in red, in radians, or in blue, in degrees. We'll move on to a few examples to illustrate this further. So in the first example here, we are asked to find the exact value of sec 11 pi divided by 6. So let's look at the 16-point unit circle. So 11 pi over 6, well, if we look, we can find it in quadrant 4 here, 11 pi over 6. So the corresponding point is root 3 divided by 2 minus a half. So 11 pi over 6 corresponds to the point root 3 divided by 2 minus a half on the unit circle. So using the definition of sec t, we see that sec t equals 1 divided by x. So sec of 11 pi divided by 6 equals 1 divided by x. And of course, if we look at the point here, the x coordinate is root 3 divided by 2. So 1 divided by root 3 divided by 2. Well, and here's the reason. When t is 11 pi over 6, x is root 3 over 2. So then simplifying this further, we see that sec of 11 pi divided by 6 equals 2 root 3 divided by 3. Here's a task for you to complete. Find the exact value of cot of 225 degrees. You can now pause the video and attempt the question, and when you are ready to continue, please press play. Indeed, using the 16-point unit circle and following the same steps as in the previous example, you should find that cot 225 degrees equals minus 1.
Now before we continue, please don't forget to like the video and subscribe to our channel. As a reminder, we offer private and group online math lessons on Zoom. The first session is always free. We cover all UAE National Curricula, American and British curriculums. We also have the best MSAT math test preparation course with a 50% discount for groups. So if you are interested in a free lesson, click the link in the description below and send us a message now. Okay, with that said, let's get back to our lesson.
We can now move on to periodic functions. By wrapping the number line around the unit circle, the domain of both the sine and cosine functions is the set of all real numbers minus infinity to infinity. Now, extending infinitely in either direction, the number line can be wrapped multiple times around the unit circle. And because we can wrap a number line many times around the unit circle, this is the justification why the domain of sine and cosine functions is a set of all real numbers. Let's consider this illustration here. Now here we have the unit circle, and here we have this arc length t, which is the number t and the number line wrapped around a unit circle, and of course, because it's a unit circle, the angle measure here also given by t. Now, we can see that if I just keep on going around the circle, well, the value of t increases. So if t is a really big number, if I wrap it around the circle, it will go round and round the circle. But eventually, I come back to the same point. For example, this point here, given by cos of t, sine of t. So we can think about this point here as being the point P, as shown in previous slides. Now, if I go around and I do a full circle, full rotation, I come back to the same point. So what this means then is that more than one t value is mapped to the same point P with each wrapping. Now, one wrapping we then consider to be a full rotation. So a rotation of 360 degrees. But of course, because we are working with real number t, this is equivalent to 2 pi radians. So because cos t equals x and sin t equals y, and as we just stated, one wrapping corresponds to 2 pi radians, it means that if I have cos of t plus any multiple of 2 pi, this will equal cos of t. So that is cosine of t plus 2n pi equals cos of t. And for the same reason, sine of t plus 2n pi equals sine of t. Because again, if I go around one full rotation, I end up at the same point. And here, of course, n is an integer, and t is just any real number. Now let's consider this illustration again of the unit circle, cos of t and sine t. Now, of course, cosine of t corresponds to x, and we see that on the unit circle, cos t, or x, is between minus 1 and 1. And similarly, y, or sine of t, is also between minus 1 and 1. So this means that the values for the sine and cosine function all lie in the interval minus 1, 1. So that is the closed interval. And repeat for every integer multiple of 2 pi on the number line, as we established in the previous slide. So functions with values that repeat at regular intervals are called periodic functions. So sine and cosine, they repeat every 2 pi, so every one wrapping, and because they do so, they are known as periodic functions. Now, more formally, a function y equals f of t is periodic if there exists a positive real number c such that f of t plus c equals f of t for all values of t in the domain of f. So, if I take a point t and I add a positive real number c to it, and I evaluate the function at this new point, and if this function equals the function value at t, then this function is said to be periodic. And the smallest number c for which f is periodic, so for which this property is satisfied, is called the period of f. So c is known as the period of f. Now, of course, the sine and cosine functions have period of 2 pi, or 360 degrees, because every 2 pi, which corresponds to one full wrapping, the function repeats itself. On the other hand, the tangent function repeats every pi radians. So the period equals pi, or 180 degrees. So much like previously, if I take the tan function, and I take this point t, and I add any integer multiple of pi, then it will equal tan t. And again, just to check that the period of pi, or period of tan rather, is equal to pi, we can look at the tan graph, and we can see that every pi radians, so here's pi, the function repeats itself. And if I go left, it's the same as I go right. So in either direction, the period is indeed pi. Let's move to example 2. Find the exact value of sine 13 pi divided by 6. Now sine of 13 pi divided by 6 equals sine of pi by 6 plus 2 pi. This is just rewriting 13 pi by 6 as pi by 6 plus 2 pi. But of course, because sine has period 2 pi, this expression here, sine of pi by 6 plus 2 pi, equals sine of pi by 6. And then if we look at the 16-point unit circle, the angle pi by 6 corresponds to the point root 3 divided by 2, comma, a half. So indeed, pi by 6 corresponds to the point root 3 divided by 2, a half on the unit circle. Now sine of t equals y, which is the definition of sine t. And therefore, sine of pi by 6 must equal a half. Well, this is because y equals a half when t equals pi by 6. Similar to example 1. And because sine of 13 pi by 6 equals sine of pi by 6, then through substitution, we can show that sine of 13 pi by 6 equals 1 divided by 2, or just a half. You can now have a go at task 2. Find the exact value of tan 420 degrees. You can pause the video and attempt the question, and when you are ready to continue, please press play. Following the same steps as in the previous example, you should have your answer to be as follows. Tan of 420 degrees equals root 3.